Hello, class, and welcome to my virtual podcast. Today, I'll be going over Earth's atmosphere, its layers, and the creation and depletion of the ozone layer. The atmosphere surrounds Earth and protects us by blocking out its dangerous rays from the sun. The atmosphere is a mixture of gases that becomes thinner and thinner until it gradually reaches space. It is composed of 78% nitrogen, 21% oxygen, and 1% of other gases. As you know, oxygen is essential to life because it allows us to breathe. In addition, some of the oxygen has changed over time, forming ozone. The ozone layer filters out the sun's harmful ultraviolet radiation. I will discuss with you how the ozone is created a little later in this podcast. The atmosphere is divided into 5 layers depending on how temperature changes with height: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. The troposphere is the first layer, and it is the lowest region of Earth's atmosphere. In this region, masses of air are very well mixed together, and the temperature decreases with altitude. The air is heated from the ground up because the surface of the Earth absorbs energy and heats up faster than air. This is the layer where all of Earth's weather occurs. In fact, the majority of clouds form in the troposphere. The stratosphere. In this layer, temperature increases with altitude as opposed to the troposphere where it gets colder. The increasing temperature in the stratosphere is caused by the presence of a layer of ozone near an altitude of 25 kilometers. Many jet aircraft fly in the stratosphere because it is very stable. In the Earth's mesosphere, the air masses are relatively mixed together and the temperature decreases with altitude. Atmospheric temperatures reach the lowest average value of around negative 90 degrees Celsius in the mesosphere. That is negative 130 degrees Fahrenheit. This is also the layer in which a lot of meteors burn up while entering the Earth's atmosphere. The thermosphere is the layer of the atmosphere which is first exposed to the sun's radiation and so is first to be heated by the sun. The air is so thin that a small increase in energy can cause a large increase in temperature. The temperature in the thermosphere is very dependent on solar activity. When the sun is active, temperatures can reach up to 1500 degrees Celsius or higher. Because of the thin air in the thermosphere, scientists can't measure the temperature directly. The thermosphere is where our satellites orbit. Science measure the density of the air by how much drag it puts on satellites, and then use the density to calculate the temperature. And finally, we have the exosphere. At very high altitudes, the atmosphere becomes very, very thin. The region where atoms and molecules escape into space is referred to as the exosphere. This is the true upper limit of Earth's atmosphere. The exosphere extends from the thermosphere out into space. Now that we have briefly gone over the layers of the atmosphere, I want to discuss ozone creation with you. First things first, what is ozone? Ozone is made up of 3 oxygen atoms, O3. The oxygen in our atmosphere that we breathe is made up of 2 oxygen atoms, O2. Because of its chemical formulation, a single atom of oxygen, O, is unstable. That is, it wants to combine with something else. That is why oxygen is almost always found in pairs, which is its diatomic form, where it is most stable. O3 is less stable than O2, because it wants to return to its diatomic state by giving up an oxygen atom. About 90% of the oxygen in Earth's atmosphere lies in the stratosphere, which is found between 16 and 48 kilometers above the Earth's surface. Ozone forms a kind of layer in the stratosphere, where it is more concentrated than anywhere else. Ozone and oxygen molecules in the stratosphere absorb ultraviolet light from the sun. This sort of provides a shield that prevents this radiation from passing to the Earth's surface. The term shield as a description of ozone in the stratosphere is a bit misleading, only because the molecules do not form an impermeable sphere around the Earth. Ozone continuously breaks apart into its oxygen atoms and reforms as oxygen molecules, so a particular ozone molecule doesn't last very long. The shield changes constantly, but the atmospheric chemical processes maintain a dynamic equilibrium that keeps the overall amount of ozone constant. That is, it would if humans did not contribute to the chemical processes. There is compelling scientific evidence that ozone is destroyed in the stratosphere and that some human-related chemicals, such as CFCs, are speeding up the breakdown of ozone in the atmosphere. And this brings me to our last topic, ozone depletion. The ozone depletion process begins when CFCs and other oxygen-depleting substances are emitted into the atmosphere. Once CFCs are in the air, they float up into the stratosphere. UV radiation from the sun then breaks apart those molecules. This releases their chlorine ions. The free chlorine ions may then combine with the oxygen ions that are in ozone. This breaks down the ozone molecules into an oxygen molecule and an oxygen ion. One CFC molecule can break down as many as 100,000 ozone molecules in this way. These forms of oxygen do not protect the planet from UV radiation and form the hole that is in our ozone. The protective role of the ozone layer in the upper atmosphere is so vital that scientists believe life on land probably would not have evolved and could not exist today without it. This concludes today's lesson. I hope you found this podcast a bit informative. If you have any questions, be sure to have them ready for explanation in tomorrow's class. I look forward to our discussions. Thank you for your time, and remember, science rules.